Okay, so in this video I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 1 from 2015, and I'm going to have a look at question 3. So this is the first part here. We've just got to complete this table here. This is to do with this quadratic function here. We have f of x is equal to minus x squared plus 12x minus 27, where x is an element of OR. And I've actually completed the table here, but we were given this y value here, we were given this y value here, and this 8 here. We weren't given these ones here that I've written in. But I'll just show you how I got one or two of them, and the others you should be able to do then. So let's take our function, which is f of x is equal to minus x squared plus 12x minus 27. First thing I'm going to do here is I'm going to do this one here. So our x value here is 5. So we put in x or 5 instead of x here. Slot it into our function here instead of x. So it's 12 times 5 minus 27. You just simply do that. So here you've got minus 25. 12 times 5, 60, minus 27. When you do that, you get 8. And I put the 8 in here. Do the same here with 6, so it's just f of 6 this time, so it's minus 6 squared this time. Remember, you're not squaring the minus here, so the minus is outside the bracket here. So we've got 12 times 6 now, and then we've got minus 27. That will give me minus 36 plus 72 minus 27. And that will give me 9. And I filled out the other ones here. We get 5 if we put in 8 and 0 if we put in 9. So you can also do this on your calculator, by the way. Most calculators will take functions now, and so you just start at x is equal to 3 up to x is equal to 9, step it up in ones, and you should get these y values. But in most exams they would expect you to do some kind of calculation to show where these y values come from. So let's have a look at this second question then. We have used table 1 and the trapezoidal rule to find the approximate area of the region bounded by the graph of f and the x-axis. So when you draw this function here, you should get something, well, you should get this here, this function here, or this graph here between 3 and 9, and what they're asking for is the area bounded by this graph, by this curve here, and the x-axis. So we're going to do it two ways. We're actually going to use the trapezoidal rule first. That's what they're asking us to do in the question, and in the next question they ask us to do it using integration, and we're going to see what kind of difference we get. Remember, the trapezoidal rule is just an approximate area under a curve, and the integration will give you a fairly accurate, or an accurate area under the curve. So let's have a look at trapezoidal rule first. So, okay, I'll just leave that there. So I'll write down the formula you need to use for the trapezoidal rule. So we're going to look at the area is going to be equal to h over 2, and then we've got y1 plus yn plus twice all the other ones then, so that's going to be y2 plus y3 all the way up to the second last one, which is yn minus 1. Now I'll just explain what they are here. So we've got h is the gap between each of these x values, so we're going up in ones. So h is from 3 to 4 is 1, from 4 to 5 is 1, from 5 to 6 is 1 unit. So our h is the same. Our h is just 1 unit along the x-axis. So that's going to be 1 over 2. y1 then is the first y value, which is 0, plus yn is the last y value, which happens to be also 0, and then we've got twice all the other ones added up. So we've already included this one, so let's start here at 5, plus, then we've got 8, then we've got 9, then we've got 8, then we've got 5, and remember we've already used the last one as well, so we don't include that again. And that's it really. That's going to be our area once we just calculate all of this. So let's do that. So it's going to be half of, let's see, we've got twice, let's see, we've got 8 and 5, that's 13, plus 9, 22, plus 8, sorry, that's 8 and 5, 12, 22, that's 30, 35, yeah, 35. So here we've got half of 70, let me just do that properly, half of 70, which is 35, and we weren't told what the units are, so we'll just write down units squared. Okay, so that's the area under the curve using the trapezoidal rule. So now what we're going to do is find the integral of f of x between 3 and 9. So in other words, we're going to find the area under the curve using integration. So we have the integral then from 3 up to 9 of our function, which is minus x squared, what was it again, plus, I've forgotten now, let me see, our function was plus 12x minus 27, plus 12x minus 27. So we want to integrate that with respect to x. So what we get when we do the integration then is we integrate each term individually, which we can do here. So this is going to be minus, increase the power by 1, so it's going to be x cubed, and then divide by the power, so that's 3. Got a plus here, this is 12, so again our power here is 1, so increase that by 1, so that becomes squared, and then divide by the power, which is 2. Here we've got this minus 27. There is an x there, but it's to the power of 0, so we don't actually include it. It's just 1 if you like, 27 times 1, or minus 27 times x to the power of 0. So increase the power by 1, and divide by 1 if you like, but I'll just leave that out. Okay, so we want to integrate between 3 and 9. Okay, so now we've just got to do the substitution. We've got to substitute in the 9 and the 3 and subtract them. So we substitute in the 9 first. So what we've got is minus, we've got 9 here on the top, and we've got to cube that and then divide by 3. We've got, actually this becomes 6 here, so I'm just going to call that 6. 12 divided by 2 is 6. I'm going to substitute in the 9, square that, and then we've got minus 27, and we put the 9 in there as well. Okay, so now we've got to substitute in the 3, and we subtract that, remember, so we've got to do the same thing again, so it's minus, we've got the 3 here, we've got to cube that, and then divide by 3. We've got plus 6, again we've got to substitute in the 3 and square that, and then we've got minus 27, put in the 3, and that's it. Okay, so after that you just got to do it. I mean, it's going to be, let's see, I'll just get out my calculator here. So we've got minus, well you've got 9 times 9 times 9, that's 729. Divide that by 3 and you get 243. Plus you've got 9 times 9 is 81, and then you've got to multiply that by 6, so that gives you 486. You've got 9 times 27, so that's 243, and it's minus as well. Over here then you just do the same thing again, so this is 27 divided by 3, so that's just going to be 9. Here we have, let's see, 3 squared, that's 9, and 6 nines then is 54, so we've got plus 54 here, and then we've got 27 times 3, which is just 81. Okay, so almost there. So here we've got minus 243 plus 486 minus 243, and that just gives us 0. So that's handy enough. And over here then we have minus 9 plus 54 minus 81, that's minus 36, but we've got a minus here as well, so minus minus 36 is just plus 36, and again that's units squared. So remember in the first part when we did the trapezoidal rule we got 35 units squared, so we weren't too far away. Okay, so it was reasonably accurate. Now it says use your answers above to find a percentage error in your approximation of the area, correct to one decimal place. Okay, so we got 36 units and we got 35 units, so that's equal to our error. So that's just going to be 1 unit. 1 unit squared was our error. So the percentage error then, percentage error is going to be that 1 unit over the accurate value. The accurate value is what we got when we integrated, so that's 36. We got to multiply that by 100, and that gives us 2.8%. And it says give your answer correct to one decimal place, so that's what I've done, one decimal place. Okay, so that's question 3 completed.